Okay students, today we can learn about Newton's second law of motion in physics, so which is required and useful for the 10th class, intermediate and JEE NEET appearing students. Okay, so Newton's first law of motion tells us what a force is. Force is a cause of acceleration. Force is a cause of acceleration. Suppose you coming here, if you take this is the object, one object. So this object is applied 200 Newton force in this direction. Let us say that mass equal to 100 grams. So because of this force, this object, the 100 grams mass object get accelerated 2 meter per second square. 2 meter per second square. Okay. Next, suppose this object is same mass 100 is equal to 100 into 500 newtons. So therefore the same object the mass is same. Suppose on this object, suppose the 5 Newton force is applied, this object get accelerated 5 meter per second square. 5 meter per second square. What we can understand here from this two, this is the force 200 newtons, here 400 newtons. The same object with the same mass, that in this case here, that is accelerated 2 meter per second square. This object is moving with 500 Newton force applying. So therefore it is get accelerated 5 meter per second square. 5 meters per second. What we can understand here, mass does not change, but because of increasing of the force, acceleration is increasing. So therefore what we can conclude here, the force is proportional to acceleration. Force is proportional to acceleration. Mass of the object is a constant. This is the one case. The another case, suppose this is the object. The mass equal to, let us say that mass equal to 100 grams. The force is applied here. Acceleration equal to 2 meter per second square. So that the force is, let us say that is equal to 200 newtons. By applying this 200 newtons force on this object, 100 grams mass, this object is get accelerated 2 meter per second square. Next I would take one more object. So the force is acceleration is remains constant. Okay, to make this object is moving with the same acceleration, 2 meter per second square. So therefore this mass equal to, let us say mass equal to 200 grams. So automatically, so on this object mass equal to 200 grams. Acceleration equal to 2 meter per second, in this case 2 meter per second. You can understand here force is 400 Newton force is applied. Acceleration equal to, let us assume this object is moving with 2 meter per second square. What is the mass of this object? You can calculate here. F equal to ma. So therefore in this case m equal to F by A. This equal to 400 by 2. This is equal to 200 grams. So that is the mass equal to 200 grams. What we can understand here, in this case the force equal to 200 newtons, mass equal to 100 grams, acceleration 200 meter per second square, 2 meter per second square. Whereas in this case the force is increased to 400 newtons. Acceleration, let us say that large size object is taken. This object is also moving with the acceleration 2 meter per second square, same acceleration both the cases, but obviously mass will be increased. We can understand here. So here in this case what we can conclude here, so if the force is increased, mass is also increased. Mass is also increased, but acceleration is remains constant. So therefore, in this case, F is proportional to m. So the mass of the acceleration is constant. Okay, so therefore from these two equations, from equation 1 and equation 2, from these two equations, so F is proportional to m into a. So therefore F equal to k into m into a. Force equal to some constant into mass into acceleration. This is the proportion. F is proportional to ma. Suppose if I want to make it equal, I would introduce some constant. That constant is influence. So F equal to k into m into a. So let us assume here, suppose F equal to k into ma. Let us say that F equal to 1 Newton, mass equal to 1 gram, acceleration equal to 1 meter per second square. If you substitute these terms, in this case F equal to k, F equal to 1 is equal to 1 k. From this, k equal to 1 by 1 equal to 1. So therefore this equation equal to so therefore this equation equal to k equal to 1. Therefore F equal to ma. F equal to ma. So therefore the Newton's second law of motion states that the magnitude of the net force acting on a body is proportional to the product of the mass of the body and its acceleration. The net force is proportional to the product of mass and acceleration. So and the another thing is that the direction of the force is the same as that of acceleration. The direction of the force same as that of the acceleration. That what we can understand here. The force is vector quantity, so therefore mass is a scalar quantity, acceleration is a vector quantity. So therefore force is the force direction is same as that of the acceleration. Suppose the force is acting in this direction, the force is acting in this direction on this body, the body is accelerating in this direction, in the same direction. This is accelerated in the same direction. That is the meaning. Of that last line. So this is the Newton's second law of motion. One is linear momentum. Of course, Newton's second law is also stated from the momentum, linear momentum. So linear momentum is the definition of the linear momentum is the product of the mass of a object and its velocity is called the linear momentum or momentum. So that means P equal to linear momentum. So if m be the mass of the object, v is the velocity of the object, that object with some m mass, it is moving with v velocity. So therefore what is the momentum that is produced? Let us assume p. So therefore p equal to, as the statement, p equal to momentum, linear momentum or momentum is product of the mass and mass of the object and its velocity. So therefore p equal to m into v. So linear momentum also has a direction like force. At any instant its direction is the same as the direction of the velocity. We can understand here p is the vector quantity, mass is the scalar quantity. So therefore from this we can understand here the the momentum direction is in the direction of the velocity, in the direction of the velocity, because velocity is also vector quantity. Velocity is also vector quantity. Let us say that this is the object. This object has some mass. This is because of the force by acting the force. This object is get into the velocity. Let us say that it is moving with some velocity. So therefore it gets momentum p. It is moving momentum. It is moving like this. The momentum is in this direction. So therefore the velocity also in this direction. In the same direction. So because how to we can understand and remember the students, the p is momentum. It is vector quantity. So therefore obviously that p is in the direction of the another vector quantity, not in the scalar quantity. Mass is the scalar quantity, so therefore it is in the direction of the velocity. You can understand from this statement. Okay, for example, if you take the heavy weight of let us say that 1 kg of 2 kg of mass, you put it on this hand. Okay, I can bear this, I can carry this 2 kg mass of the object, 2 kg mass of the object. Suppose that 2 kgs of mass is moving with a certain velocity and hit my face. Obviously my face get damaged. My face get damaged. Whereas the object in the stationary 2 kgs in my hand, I can carry, I can bear, I can stable. But whereas I am happy, I don't get any pain. But whereas the 2 kgs mass is moving with certain velocity and hit my forehead, obviously I get injured. So because of why the mass is in the stationary, object is in stationary, I didn't get any damage. But that object is moving with certain velocity and hit my head, obviously it is my head get injured because of momentum. P equal to m into v. V is added, so that because of this momentum, my head get injured. That is one example. Another example, if you take that when the students are jumping long jump or high jump, generally you see that this is the long jump. Obviously you see that they are provided sand bed. This is the sand bed. They are not provided any hard surface of the bed. Here they can provide only sand bed. Why they can provide of this sand bed? The moment the person is coming over here and jumping over this line, because of the sand is wet sand is provided generally, because of when they are jumping and suddenly they step on this sand surface, that because of that momentum, that foot is penetrated into the sand, so that that momentum impact is reduced. No injury is happened. The comfortably that you can jump and it is comfortably jump. No injury is taking place. Why? Because that sand is because of that person momentum, it will be penetrated, so that this impact is reduced. The momentum impact is reduced. It doesn't get any injury. If it is hard surface, obviously if it jump on this hard surface, there is a possibility to that there is no penetration. So therefore this leg or anything may get injured, because suppose here is also P is equal to mv. While it is jumping, it is penetrating. This momentum is taking some time into the penetrate. While it is penetrating, it taking some time is traveling, so that it is penetrated. That time then if you make it that momentum is divided by that traveling time t, this becomes force, that becomes a force, that becomes a force. So therefore mv by t equal to momentum by t, this becomes force. So therefore what is happening, let us say that the time is equal to 2 seconds, 2 seconds, let us say that time equal to P equal to mv, okay, let us say that this is the 10 gram meter per second square, let us say meter per second square, it is the okay, this is the thing. Next, while it jumping, it is takes it while it is penetrating, it takes some time, let us say that the t equal to 2 seconds, 2 seconds, that p is divided by that momentum divided by time. What is happening, that is equal to f force, it becomes force, m equal to v by t, so that what is happening, 10 by 2, this becomes 5 gram meter per second square, so that what is happening here, the impact is reduced, so therefore there is no possibility to get injured. Otherwise if you jump on the hard, suppose hard stratum, and no time is taking place, when we jumped on this hard surface, the same force is exerted, so that there is a possibility to get injured. That means the p equal to 10 kg meter per 10 gram per meter second, so therefore f equal to no time, that m equal to, let us say that 1 second, even you can 1 second, you take, let us say that in case 1 second, what is the force is here, force equal to mv by t, this is equal to 10 by 1, this is equal to 10 gram meter per second square. In this case the time equal to 2 seconds, the force equal to 5 gram meter per second square. In this case time equal to 1 second, 10 gram meter per second square force. That much of force is exerted here, there is a possibility to get injured. So that is the mechanism in this, that is the importance of this momentum equation, p equal to mv. Like this you can take another example, while you take a cricket ball, while it is the fielder he wanted to catch that ball, obviously what we can give the guidelines, that fellow, the ball is coming here, you put it here hands and you take it back hands, so that what is happening, you can apply the small force and traveling certain distance, certain time, so that the impact is reduced, so that comfortably we can catch that ball. Whereas suppose unfortunately the ball is coming like this, you put it hand in this direction, the time is less and you are applying the more force while catching that ball, so that sometimes the ball is impacted on the hand, injured, or the ball may be get out from the hands, they are unable to catch that ball because the force is more, so this is the another example we can take to understand the linear momentum equal to mv, and what is where it is applicable, the application of these in these cases, the application of this momentum cases, these things. This is the one thing, the person is any person is jumping or high jump or long jump, obviously they are provided a sandbag, that is the reason they don't provide hard while this is the concept is applicable in the while you are catching the ball, obviously when catches ball is liking that the ball is taking place and the pull it back, so that comfortably we can take that catch, because when we are put it here, the less force you are applying in this direction and pull it some time, because of that the impact is reduced, the force is reduced, that is the thing we have to understand in this momentum. So therefore students, the Newton's second law of motion can be stated in terms of momentum, you see that the statement, The rate of change of momentum of an object is proportional to the net force applied on the object. The rate of change of momentum of an object is proportional to the net force applied on the object. The direction of the change of the momentum is the same as the direction of the net force. So you can here we can understand this statement by taking this example. This is the object. Let us assume. So the mass of that object is 100 grams. Let us say that this object is moving with velocity, going with velocity 2 meter per second square. Let us say that the time traveled equal 1 second. 1 second. In this case, what is the force? Mass into velocity by time. So therefore you can get F equal to mass mv by t. This is equal to 100 into 2 divided by 1. So therefore you can get 200 newtons. The same object, suppose the force is enhanced, increased, the mass is same, so that obviously that object is velocity is increased. The object velocity is increased, so that object velocity is increased to 6 meter per second. Suppose that in this instant, in this case, the same object, the force is increased, velocity is increased to 6 meter per second, that is traveled 2 seconds. So that in that case, the force equal to 100 into 6 divided by 2. So therefore this get 50 300 Newton. You see here. So what we can understand here, what is the statement? The rate of change of momentum of an object is proportional to the net force applied on the object. So the force is increased, the momentum is increased. The force is increased, the momentum is increased. Of course, net force we can take in different cases. Suppose, of course, they both are the object both are traveling in the same direction. The one object velocity is more. Obviously, it can bombard hit that second object, or the two objects are moving in opposite directions. We can see that in these cases in the while we are solving the problems. So we can understand here. So the rate of change of momentum of the object is proportional to the net force applied on the object. So the force is increased, the momentum is increased. In case the object, the momentum, if the object mass remains constant, why it is make it remain constant? To understand that statement, 200. So therefore net force equal to 300 minus 2, that is the 100 newtons. So from this you can write this equation. Okay, so therefore the rate of change of momentum is I can write here P2 minus P1 by T2 minus T1. So already I explained here how this is proportional to the rate of change of momentum is proportional to the net force applied on the object. In that case, let us say the same object M moving with V1 velocity, moved with T1 seconds. Already we see just before I explained with numerical values. So that same you are assumed here. P2 minus P1 by T2 minus T1. So therefore P2 minus P1 by T2 minus T1 is proportional to F force. According to second law, P2 minus momentum, the P2 minus P1 by T2 minus T1 is proportional to force. So therefore force equal to, I would like to introduce K equal to, so K into P2 minus P1 by T2 minus T1. So where K equal to 1 already I explained how we get the K equal to 1. So therefore F equal to P2 minus P1 by T2 minus T1. Where P2 equal to, what is P2? M into V2. P1 equal to M into V1 divided by T2 minus T1. So you take M common, so that V2 minus V1. So that this is equal to V2 minus V1 by T2 minus T1. Again you can get M into change in velocity divided by change in time. So what it becomes? This becomes acceleration. So therefore that is equal to M into A. So finally F is equal to M into A. So therefore the Newton's second law is expressed, stated in terms of momentum also. This we have to understand. Yes.